So when Scott was in the classroom talking about aggregate, the consensus properties, he talked about what? He talked about the fine and coarse aggregate gravities, sand equivalency, fine aggregate angularity, F&E, and coarse aggregate angularity, right? So let's tackle the easiest one first. How many in this group has ever run a coarse aggregate angularity test before? You have? You? So that's 2. The only time I ever run this test is here. Why is it, do you think? So out of the plants, the company I work for, we have 10 plants, and I've never, ever ran this test before. The reason I don't run these tests at any of our plants because all our aggregate is quarried. It's all blasted, it's all quarried. So the coarse aggregate angularity is typically done on what? Gravel pits and river stone, right? So Scott was talking this morning, we gotta go through, you bring your sample into the lab, you go out to the stockyard, you get your loader to make a mini stockpile, you bring your aggregate, and you gotta read your test method, and it explains in here how you obtain your sample from your stockyard. So you bring it in, you break it down, and you get the required amount of weight or pieces to run this test. And once that's determined, you've got to go through each piece. This is a good example right here of no fractured faces. Correct? I mean, there's no broken areas. It's all rounded, right? So you would separate these into piles. No fractured faces. What constitutes a fractured face? Does anybody remember from what Scott said earlier? 25% of the whole area, right? So you look at this piece of stone right here, would we classify that as 1 or 2 fractured faces? Probably, because that one right there probably doesn't constitute 25%, right? So that would go, so you're going to have 3 piles here, no fractured faces, 1 fractured, and in this case, maybe 2, none, 2. It's a judgment call. I don't think there's any technical way you can actually measure. So then if you look at your specifications, it's in section 211. Section 211 under table 212-A, you have specifications for 1 fractured face and 2 fractured faces. Tomorrow we're going to do the math work in the classroom. I'll be teaching that part, and this will be like one of the easiest math questions on your exam. So on your 1 fractured face, you got to have it has the minimums for 1 fractured and 2 fractured face requirements for your specification requirements.
You bring in your large sample, right guys? You split it down. You don't just randomly pull out handfuls. Split down till you get a representative sample size. And you literally pick up every piece and make a judgment call that's at least 25%. That's 1, that's 2 fractured faces. And then you weigh each pile, and then you'll do the math calculation we're going to cover tomorrow. That's all there is to it.
So why is it so important to run this test? So let's say you work in a part of the state where you do have a lot of gravel, you do have a lot of river stone, right? That illustration that toward the end of Scott's presentation, if you have a lot of rounded aggregate in there, what's it going to do under traffic? It's going to move, right? It's going to roll out, be ruddy. So, so I won't talk about this test until this time next year, because all the products we use is quarried, it's blasted aggregate. It's really not a problem for most of us asphalt producers.